Okay. Hello, everyone. Good morning, good afternoon, good evening, depending on whether you're joining us on land or on sea. My name is Natasha, and I'm one of the Paleo-research committee members, and we are very excited to have a very special edition of the Paleo-research seminar. We will be joined by Team JOIDES Resolution, and they're currently in the Southeast Atlantic Ocean, and they'll be talking to us about paleo-research at sea while on board the JOIDES Resolution. Before we get started, a quick format of today's seminar. We will do a quick welcome and announcements, followed by a very special talk where we will get to see what happens on the JOIDES as they are pouring currently. Following which and during as well, we will also have question and answers. So if you have questions while the tour is going on, feel free to drop them in the Zoom chat. And if you have specific questions as well, feel free to drop them to the questions Paleo-research host, who today is Remat. Paleo-research values the participation of all folks interested in paleo sciences. And please remember to abide by a code of conduct during today's seminar. If you find yourself to be muted, please mute yourself for the duration of the talk. And again, you can ask questions by chatting to the questions at Paleo-research host or by using the raise hand function. Any technical issue should also go to the questions at Paleo-research host, who today is Remat. We do have closed captions built into Zoom. For that, you can use the CC button to show or hide them. And if you know any outstanding early career researcher, please nominate them. There will be a link for that will be dropped shortly in the Zoom chat. Another link that will be coming in is a weekly feedback form for demographic information. It's anonymous, optional, and highly encouraged. Okay, so welcome to our speakers. We have Claire Routledge, who is a postdoctoral researcher at the Institute of Geosciences at the University of Kiel in Germany. She is currently sailing on Expedition 390 as a nanofossil micropaleontologist. We also have Wang, who is a postdoctoral researcher at Woods Hole Oceanographic Institution in Massachusetts in the United States of America. She is sailing on the expedition as an inorganic geochemist. And we also have Andrew McIntyre, who is at the Open University in the United Kingdom, and he is sailing on the expedition as a properties specialist and a stratigraphic correlator. And then we also have Laura Guertin, who is Expedition 390's outreach officer. And with that, Laura, I'm going to stop sharing my screen, and we look forward to the session.
Great, thank you very much. And hello everyone from the South Atlantic Ocean. My name is Laura Guertin, and one of my duties here on JOIDES Resolution is to offer tours of our ship, let everyone know what we're doing in terms of our scientific objectives, let people know a little bit about what it's like to live and work at sea, and of course give you an opportunity to meet the scientists. And we've got the 3 that were highlighted already that are standing by and waiting for us. So I'm going to go ahead and get started. And I always, with these groups that I meet with, I like to start with a visual aid, as I'm a faculty member myself at Penn State Brandywine in Pennsylvania. And I like to show visuals just to bring everyone on the same page, so to speak. And this visual is really representative, I think, of what we are shown in our earliest years. So in school, when we're learning about geography or learning about the world, this is typically the representation we see of planet Earth. We see what we call political geography, right? So all these colors represent different countries, and then you have one color blue for all of the ocean. Now, yes, we do have one ocean on this planet, right? It's one ocean covering 71% of our planet, but roughly about 20% of it is all that's been explored. We have so much more to learn about our planet. And so it would be great if we could really broaden the idea and the way that we introduce our ocean to students, especially at very young ages too. So I'm going to bring you over to my, when you're at sea, your classroom is a little different when you engage with people too. So I have this bulletin board with some visuals on it. And And with this expedition too, the way that it was designed and put together and the way that we share it, we talk a lot about planet Earth from a systems approach. So thinking about, yes, we're on the water. So we have the hydrosphere. We are looking at a microbiology component. We'll talk about that in a little bit too. And that would be our biosphere. Lithosphere, of course, is that ocean crustal material that we're collecting and sampling. And then the atmosphere and how that has interacted and influenced our ocean over geologic time. So I really like the idea of thinking about Earth in all of these parts and not necessarily breaking down the planet based on different countries, because our air completely circulates, right? Our waters completely circulate the planet. And so let's take a look at specifically what we're trying to do here for Expedition 390. So for Expedition 390, we are on the scientific drill ship JOIDES Resolution. There are only 2 ships right now in the world that can do this type of research. So you have the Chikyu over in Japan and the JR, which is how I'll refer to it in the expedition. And we left back on April 12th. We left Cape Town, South Africa for a 2-month expedition. All expeditions on the JR last 2 months in time. And what we did was we sailed from Cape Town. We went across the Mid-Atlantic Ridge, so the divergent plate boundary that separates the African plate from the South American plate. And we're just on the opposite side. And what we're doing is we're actually coring through the sediment and that basement crustal rock. So the basalts that are down here. We're on a transect that is perpendicular to the Mid-Atlantic Ridge. So pretend this divergent plate boundary is coming in and out of the board at you. We're on this perpendicular transect here. And what we're doing is we are going down and we are collecting the sediments on top, including everything that's in there, drilling down into this basement material and bringing it up. And a couple of our main research questions relate to this material. One, we're really interested in what happens to the basement material through time. So we know when you have a volcanic eruption and that material cools, that's going to be your youngest material. And the further away you go from the ridge, the material gets older. So we know that basic age structure, but we don't know how things age. So we know it gets older, but what happens chemically to this material? What's happening physically to the material? What's happening to the water that is circulating through here as well? What influence does that have? So these are some of the questions we're trying to address. With the sediment layer also, we're interested in looking at the microfossils that are in there too and how those changes are also happening. But then we've got this microbiology component on this expedition, which is super exciting. We're really interested in looking at also what's living in not just the sediments, but in that rock as well. So, and how do those assemblages change in time in terms of their diversity, in terms of their abundance? And so we're really looking at changes over time as we're moving away from the Mid-Atlantic Ridge. This particular location is really exciting for us to be sampling from because this is the general area that back in 1968, the first scientific drilling vessel, Glomar Challenger, visited. So we're in that same region, and Glomar Challenger, on its 3rd expedition back in 1968, sampled in the same region. And the materials and the samples that it brought up actually helped us understand the ideas of seafloor spreading and proved the theory of plate tectonics. So in terms of thinking of a legacy expedition and the contributions from back then, here we are 50 plus years later. We've got a new ship. We've got new research questions, new technologies that allows us to be able to learn a little bit more about what's going on in our ocean, which again is such an undersampled area and has so many questions for us. So the ship that we are on it's down here. I apologize. There's a little bit of an angle here. This is our ship, JOIDES Resolution. And what we're going to do now is I'm going to take you on a walking tour around the ship. So let me go ahead and grab my hard hat and we're going to get started. And then what we'll do is we're not going to be able to see the entire ship. But what we're going to do is then go through some of the areas, go down into the core lab, and that's where we'll meet with the 3 scientists that we're connecting with today. I apologize if there have been some sound issues. It's one of the great things about technology is we can connect from the ocean, but we're also on the ocean. So if for some reason the internet drops out or I drop out, just hang tight. I'll be able to pop back in. This is not uncommon for us in terms of internet access on the ocean. I'll just quickly stop at this map here. This map has a lot of dots on it. Each of these dots represents where either the ship Glomar Challenger our ship JOIDES Resolution, or the ship from Japan, Chikyu, has actually drilled into or through the sediments and or the basement material. And so you can see, especially the region where we are, we initially, again, departed from Cape Town, and we're in the region where you see these pink dots. There's not a lot that's been sampled and collected from this region. So we're excited to be here. This expedition, believe it or not, was initially proposed 9 years ago. It's taken us quite some time to be able to pull together all the resources, the material, the scientists. Unfortunately, COVID did set us back. This expedition was originally supposed to sail in October of 2020, and we're excited that we were able to get out of port this time. So now we are exiting into what you really want to see. So welcome to the South Atlantic Ocean. It's pretty amazing being out here because I think one part of the earth sciences is really the way we work with spatial and temporal scales. And when you're out in the water like this and you see nothing around you but water, I think it really puts into perspective how massive this particular system is. We haven't seen too much life out here besides ourselves on the ship. We have seen a couple of whales, we've seen albatross, we've seen mahi-mahi, mola-mola, so there's various fish species. Once in a while, a cargo ship is off in the distance, but pretty much it's us out here. In terms of us, there are, the ship can support 120 people. So typically that's split. Half of them are scientists and technicians, and the other half are the crew. So the captain and the bridge crew, or the other supporting engineers and people that are making our meals, people that are taking care of our rooms. This expedition, we have 113 people that are on board with us for this 2-month expedition. I always just stop briefly here because for the younger students that I connect with, safety is always a big question. Because I mentioned how exciting it is to be on the ship and we're in the middle of the ocean and we're so far away from everyone. And I will typically get questions. What if you don't know how to swim? Or what if you have to evacuate the ship? Well, we have emergency drills that happen every single week. In fact, an hour and a half after we left the port was our first emergency drill, the abandoned ship drill. This is one of our lifeboats that's on board. We have 4 of these lifeboats that can hold 70 people each. So we have double the capacity that we need. We have not had to use them. We don't anticipate that as well. We have had some rough weather out here. We've been experiencing a little bit of a heave. Heave is the up and down motion of a ship because of the waves and the swell. We did hit over 20-foot heaves the other day. We had to suspend our activities, but fortunately we are collecting core right now. So I'm going to step back a little bit because it's hard to fit our drilling derrick into this iPad screen. But here we are. So the length of the ship is about 470 feet in length. That's the length of 5 basketball courts. That drilling derrick in height is 200 feet from the waterline. That's about the height of 20 basketball hoops. And I like to mention basketball just because I'm a huge basketball fan and it's the NBA playoffs back home and I can't watch any of them. So on the ship, we do not have live TV. So there's no watching YouTube, there's no Netflix, and what we resort to is the incredible library of movies. We do have a movie room on the ship. We do have an exercise room on the ship. And if you're really inspired and want to do some walking outdoors, that helicopter pad that's all the way in the back of the ship, you can do 79 laps on that, and that'll be the equivalent of a 5K. So there is a little bit of chance to go outdoors. What you're looking at now is the drill pipe. You see this yellow pipe here that's rotating, and what that is, it is touching down. We are into basement rock right now, and it's drilling through, coring through that material. We'll take a look at a drill bit in a sec. And it looks like it's bouncing up and down, but it's not. That is actually secure at the bottom of the hole. It is the ship that is bouncing up and down around it. So what we have at the bottom of our ship, I'll quickly share a picture. We can't go there because it's not open at the moment, but this is what's called our moon pool. This is where we down either our camera systems or our pipe that then continues down. We're in about 5,000 meters water depth here. So down 5,000 meters to the seafloor. All right, we're going to go around now and down into the core lab area so we can connect with our scientists. It's a lot of fun to come out here and watch them as they're pouring through. This is our catwalk where we bring our completed core once we pull it up. These are just some examples of some of the drill bits, and it depends on what you're going through. If you're going through sediment or you're going through rock, is what you use on the bottom. These are upside down, so you would have to invert them 180 degrees. So as you saw that yellow pipe spinning, each of these wheels will also spin, and then we collect that core material through the center of it. So I'm going to go ahead now, and we're going to enter the core laboratory. In this laboratory, it's not just the scientists. We have computer programmers. We have IT people. This ship has to figure out how to make science work when you can't run to the hardware store. You can't go to the computer store to buy anything either. This ship is filled with incredibly resourceful, creative people that can get the job done. So our trio of scientists is right here, and we're going to start with Andrew. So Andrew, I'll turn it over to you.
Sure. Hello everyone, welcome to the core lab. This is the core lab where we do most of our measurements. The first people to get hold of the samples after they've come on the catwalk are the physical properties team. So I'm one of the 4 physical property experts on this expedition. And if you come this way, we can show you some of the machines that we run. These are the physical properties tracks. We put the 4 sections onto these tracks and we measure the physical properties. The first physical property we measure is GRI density. This characterizes the density of the sediments or the hard rock that we're currently doing. And then we also measure magnetic density. This can help us, those two together, can help us characterize the initial characterization of the sediments, the hard rocks. It can tell us about the chemical composition, the structure, the fabric of the rock, there's about the porosity of the rock. There's all these important first characterizations of the whole round sediments. And then we go to the next track. This machine is a NGR, natural gamma radiation. This measures the decay that's being released from sediments. So it will tell you about the potassium, the thorium, and the uranium content of the sediments and the hard rocks. And this helps us characterize, particularly when you've got transitions between clays and carbonates, the NGR will pick up those transitions because clays have higher potassium content than the carbonates. So when we have all this physical properties data, my second role on the ship is stratigraphic correlation. So we take the physical properties data that we just collected off the cores, and we come over to this station where I can correlate the data that come in. So when we ocean drill, we don't just drill one hole, because if you drill one hole, you're never going to get complete recovery. We drill multiple holes, and what we do is when we drill the second and third holes, we are live correlating as you go down the physical properties, so we can track exactly where we are in the second hole compared to the first. This is particularly important because we can then live correlate over recovery gaps, so we can guide the drilling to recover these gaps so that we get complete deposition. What we do is we look at the wiggles in the physical properties, we tie it across the holes, and then produce what's called a splice. A splice is a complete section where you're switching between sites to get that complete recovery. And that's particularly important for paleoceanographic research because when you have a complete record, you have a complete record of time. So then when you start plotting other data sets and the isotope data, for example, you'll have a complete record of time going down forward. So once we've done the initial characterization in the physical properties group, we move down the core lab. So currently it's in a whole round form. So what we do is we take it down here to the splitting room, and the cores will get split in half. Find out guys.
There, I'm coming very quickly.
Yeah, so this is the splitting room. This is where we'll split the core into its working half and its archive half. This allows us to then, so once they've split, they come out into the rest of the core lab, and we have Claire. Yeah.
Hello, everybody. So we're a little bit different today in that we've got basement, we're basement drilling, and I'm usually working on the sediments, but the process is still the same, I guess. We've got our description, working half table, so as it was a split, one is archived and the other we use it to describe, and the other is the sampling table.
We're just going to take a quick look at these rocks here too.
Yeah, so these are some of our riches that have come up from the basement today. I think it was this morning.
Yeah.
And we have patrologists on shift, both one on each shift, and they are describing spend the entire day describing the cores. We also get image and density, moisture density get taken. Yeah. So actually, it's probably a little bit more Andrews. There's other physical properties on this side that happen with the split cores. Discrete samples are taken from the Paleo-mag section. Chemistry, all sorts of analyses are done. I work on the sediment, so I'm a paleontologist. I take a sample from each of the core sections and look at the calcareous nanofossils that are in there and assess the age of each of the cores. But when they come out here, that's for every core that comes up, we go out with a little bowl and collect our core catcher. But once the cores have been split and are laid out, I also take section samples to refine the age model because, as you can imagine, 10 meters, a lot of time can pass within that, especially if we've got transitions like big boundaries, Oligocene, Miocene, Eocene, Oligocene, that sort of thing. Here we have the oldest material we have is Middle Paleocene, which is around 61 million years, and we've taken samples from the sediment basement interface and gathered that from the microfossils, and we actually, interestingly, have a fin section that has some carbonate in it from these breccias, and we can confirm that it's all sort of similar age. So that's me. In the core lab, I actually have a very fancy microscope. We have a room full of microscopes, and patrologists also look at fin sections. I think that's. I mean, for me personally, I'm interested in reconstructing past climate and ocean conditions. The Southwest Atlantic is fairly under studied. We have some good sections from the Southeast Atlantic, but we are the South Atlantic gyre system. I'm really interested in the information of this and past climate or Paleogene, early Neogene. Sort of stuff. We've got some really interesting intervals and some really interesting sediment that we've recovered so far, so it's going to be a fun few years ahead. Obviously, this is just the first start where we recover it. We have our sampling party January next year where we really heavily sample and probably start our post-cruise research. So when we come on, we all have to put together a research proposal, and in there we target, we tell everyone what we're interested in. We align with some of the other researchers on board, scientists, and that's part of being accepted onto the expedition in the first place is tying everybody's research proposals together. And this expedition is more, not more, but some of the primary objectives are to do with the basement and some spreading and that sort of thing. So sediment is a secondary objective on this expedition, but it doesn't mean it's any less important for some of us. So that's sort of there are plenty of cores out.
Plenty of core, yes. But I think we need to move on to E in the interest of time.
Okay. So hi everyone. Actually my lab is downstairs. I work as an eoPERCS economist out of Australia. So this is the core lab, and my job is doing chemistry, which is all downstairs, and sometimes also help sampling, help with microbiology sampling. So basically, what we do on the ship is we for the sediment part, we extract the interstitial waters, so the core waters in the sediments using the squeezer. We also do the rhizome sampling, so we have have a syringe over there and have a rhizome in there to pull out the cold water from the sediments. So we take IW for shipboard analysis, which would include the regular analysis of pH and salinity, but we also run the major cations and anions using ion chromatography. We also have very nice new ICP gas inductively coupled plasma atomic emissions spectrometer on the ship, which allows us to run both the major and minor elements at the same time. We also run some carb samples from the sweet cake that we got from the NW. So carb samples we will run the carbonate content and organic carbon. Just give you some idea of how much productivity we might have at that point. So for the basement part, my job is to go up to the sample table and select the samples that we're going to run on the ship. The ICPA gas is not only used for IW, it's also used for the solid sample we see here. And we are targeting some salt over here and see if there is any changes in the salt. So personally, I'm a geochemist and oceanographer. So my past research was mostly on the more recent stuff, the past 10,000 years in the Holocene. But right now I'm also including my time interval to like a longer time span than Pliocene life or even deeper. So primarily I'm interested in the oxygenation changes or redox changes in the past ocean and how we can use sediment to reconstruct the oxygen variability and how the oxygen changes are correlated with the other circulation changes or temperature or pressure.
Great. So do we want to get the three of you together? And there's some questions that it looks like might be coming into the chat. So we're going to go in you'll be able to see a little more as I walk through here. There's our magnetometer. Down here is all the microscopes that are petrologists also that are looking at thin sections. Claire, who's doing the micropaleontology. We also have, and we have a panel here. All right. So this is wonderful. They were prepared for this. So does anyone have any questions?
Yeah, great. Thank you so much for showing us around, and this has been pretty awesome just seeing everything. We do have a few questions filtering in. I'm going to read them out loud and then also drop them in the chat box, in the Zoom chat. So the first question is, how many scientists are on the ship and how many technicians and crew?
So there's 113 of us in total on board right now. So we're about split half and half. So half are scientists and technicians, and then the other half are the crew.
Okay, perfect.
There's 22 scientists, so there's roughly 11 on each shift. That's currently a few below what is normally the case. We're a little understaffed on this expedition. There's a couple of pathologists that can make it, and microbiologists that can make it. So.
And micropaleontologists.
And micropaleontologists, yeah.
We're understaffed in almost every area on this expedition. And geochemists. Yeah. So, but yeah, we work 12-hour shifts though, so there's always somebody covering every specialty discipline.
Okay, great. Thank you. Another question from Chelsea. What got you all interested into working with core samples?
Well, most of our research has been using IDP material. The idea of getting a complete record of time, you can't really get that too often on land, so you're sort of resulted to marine sections, and the best source of core material is ODP and then IDP as an amount of that. So it's a natural choice to take the best samples you can get. And it tackles so many questions in paleoclimate. How the oceans have changed across the geological time, looking at how the microorganisms have changed also through microbiology and microbiology. Yeah,
So I mean, I study marine organisms, so like Andrew said, it's hard to find complete sections on land, and with marine stuff, I need some form of ocean past or present for them to have even looked.
Like for me, my interest is in oceanic oxygenation, so I have to go to the ocean. Well, on the other hand, like your reconstruction of marine oxygenation can be an indicator of how much atmospheric oxygen you have in the gas as well. So you can have both of the information that you, and for terrestrial, you can only get atmospheric.
Cool. Thank you for answering. Another question that's come through by Morrison Nolan is you are able to, okay, I think this is also like a curiosity question. You're able to make thin sections while at sea. I bet that's precarious with the waves.
There's a few things that are precarious with the waves, but we do have a thin section technician on board, and so the meteorologists and other interested parties do request thin sections, and I think he's pretty speedy at making them. And they're really well made, so yeah.
You can make up to 12 a day.
There you go, 12 a day.
By the way, they have the polisher downstairs, so you don't need to polish your thin sections by hand. They have like two polishers, like one rougher one. One is rougher, one is like more like a small size, whatever. So they can do this pretty quickly. They have a lot of instruments on board that can help you. We have, pretty much everything that you could want in a lab. We have some, or if we don't have it directly, there's a technician that knows how to manufacture it for you. So we're really well equipped out here.
Claire, do you want to talk about some of the challenges you have just looking through a microscope?
Yeah. So, I mean, like you said, with the waves trying to make a thin section, we have issues either measuring samples, even when you've got waves, but also I spend, calcareous nanofossils are between 3 and 30 microns big, so they're extremely small. The magnification we use to analyze our samples is quite high, and so even just the movement of the boat, generally we adjust focus often, but it goes in and out really quickly, and sometimes when we just had a storm pass through and we have microscopes equipped with cameras, but I wasn't able to take any photos of these samples because we were moving so much that I was spending so long trying to just click it in time to catch it when it was in focus. So I gave up pretty quickly. Some of the issues, as well as working your eyes particularly hard when we're moving.
I think we have the balance issues.
Yeah,
because like on the ship, you cannot. The balance doesn't work very well if the ship is like bumpy and like moving around. You have to have two balances in parallel. Like one is a reference, one is a real like weight balance. Just need to compare the two balance, the difference between two balances all the time to take vibration into account. So that will require you to do like more measurements for each sample. Like we do 500 times of measurements, which takes several minutes. And it's even harder if you want to weigh out accurate, like for QC or for these samples. It's very hard to
Cool. Okay, awesome. We have a few more questions that are coming in. Another one, Laura asks, nice seminar, very interesting. I would like to ask, are there some trainings before the cruise, a preparation period? Thank you very much.
So eCord, so in Europe, eCord has a training program which you can sign up to, and you can learn some of the basics of all the different research groups. Unfortunately, that wasn't available because of COVID for me, but I know that that's definitely on the plans for the future exhibitions. So.
Yeah, I mean, with each of our specialties, we are trained ourselves with what we're working on, and then when we get on board, each of the we have a few days of instrument training and sort of being told how things, I guess, work specifically at sea and with these specific instruments. So we are all experienced in our individual and respective fields, and sometimes people are working a little bit sideways, laterally, I guess, with their expertise, but it usually all ties around back at the end. So.
Cool. Okay. Another question that came through, what microfossils are in abundance around the area in which you guys are sampling in? Ostracods, foraminifera?
Yeah, so we have, on board, we have a plastic foraminifera specialist. I do the calcareous nanofossils, and we also have a shore-based benthic foram specialist. So we are all working together that's just on this expedition itself, we are all working together to develop the age models. We have a couple of different intervals where we see a few more silicious organisms, but in general, we don't have on board anybody that is silicious specialized. And yeah, I mean, usually there are two micropaleontologists per specialty, and they work opposite shifts. But like I mentioned, we're a little understaffed, so I'm on one shift and a 4-AM worker is on the other. At crossover, we will discuss what each of us has seen, and we have a nice whiteboard, and we've written up there each of the cores that we're finding, and then the age of the material that we are seeing in that course. So we're trying to keep each other up to date. But some expeditions, they have palynology and they have diatom radiolaria specialists, but this specifically we're on just looking at the calcareous microfossils on the ship. But I mean, once the cores come out of moratorium, there's plenty of room for people to look at other microfossils.
Just to clarify, Claire mentioned crossover. And so again, we're each working 12-hour shifts. So you're either working 12 noon to 12 midnight or 12 midnight to 12 noon. And so we're split between the halves. And so at those points, you meet with the person that's coming on. So the person rotating off and the person that's rotating on always touch base with each other and talk about what just happened during that shift. Hey, we saw this, we need to go on to this. So there's always communications and meetings going on with the people in your subgroup and also across the entire science party.
Okay, yeah, thank you for that clarification. Another question that's come through is, what's the constant beep on board the ship? Is it one of the scientific equipments or the ship protocol?
That would be our magnetometer that has this whistling that seems like almost every tour picks up on that noise. We can't silence it though. It's just, yeah. So that's, I think we've tuned it out in some ways because it's always going on.
It's all background noise now.
But whether it's a magnetometer on land or at sea, they all make that chirping noise. So.
And all the tracks make a distinctive noise. So I know if I'm looking at one track, that's the noise of that one finishing. So I know I can go around the corner and it's done. So.
I just listened to the core on deck call. Yeah.
Oh, we don't have the hammering noise though.
Oh yeah, sounds good.
Yeah, so because we're understaffed for the microbiology group, so for this cruise, geochemists are helping the microbiology sampling. So when they are doing the rock sampling, what they do is they take the whole round from the core and they hammer and chisel off all the offside surfaces, and they will keep the inside pieces. So whenever there's a core on deck, basically everyone, like maybe in this lab or like in the science office in the galley, would hear us hammering the rocks for like an hour.
Awesome. Cool. Okay, so another question that's come through is, have there been any surprises so far in the core recovered?
Claire, you had a surprise for possibly something you saw.
Yeah, I found some in the nanofossils. I found a species that is a little different to what I have seen before. I guess I'm not going to quite call it a new species yet, but it just is just it's a disc. If anyone knows or studies, it's a discoester, and this specific species has 6 arms or rays usually, and in a couple of different samples, I found one that had 7, which is not that normal. So that for me, that was quite exciting. I know it's a really little things, but yeah, it keeps us going, I guess. And I don't know if you guys otherwise.
What's really surprising things, just more of the speed at which sediment comes in.
And then how it all comes together. I mean, for us, we were quite lucky in that, especially on the biostricography team, the expedition, we had 2 engineering legs or legs ahead of us, and they prepared the holes for us. So when we're having re-entry, the re-entry cones and all that sort of stuff was already done for us. So we could come and just keep drilling. And with that, they poured some of the sediment, and the biostratigraphers for this expedition and the next one, which are the transect legs, we received that sediment in advance, and so we had a bit of a early look into what we were expecting. So in some ways, like, we kind of knew what was coming, but seeing it, yourself in person, the whole course, it's kind of cool. And then I guess none of us knew what was going to happen in the basement. So yeah, and I've never really spent much time looking at basements, so I'm impressed every time I come up.
Yeah, it's pretty impressive recovery we're getting.
Yeah.
Consistently in 60-70% recovery for basement.
Yeah, 3% recovery.
Yeah.
For the basement, it's like, oh, we finally need to use the CSV.
Yeah, so
scale.
So basement is usually traditionally very hard to drill, and core recovery is often they're happy with 30%, and we're doing exceptionally well. I think ours are 60 to 100% sometimes. So our basement experts are pretty tough.
Cool. I think you sort of answered this question, but there's a question by Laura. What proxies in the sediment are most useful for the time periods you target? What are the best proxies from the basement rock?
So, the sediments, the classic paleo, so carbon, oxygen, isotopes are the go-to first. Then I look at neodymium isotopes. I can tell you about water mass provenance and how the deep ocean, how the signature of the deep ocean and how that might have changed over time. That's one of the sort of secondary goals, looking at the evolution of different water masses at depth and when they reach the southern Atlantic. So neodymium is going to be a good isotope technique to tackle that question. In basement, you could be looking at various different rare element profiles. Strontium, neodymium isotopes could be useful for tackling questions like the heat flow through oceanic crust. They often look at the mineralogy, so XRD, XRF, to characterize the different alteration mineralogy that they've got in the basalts in particular.
I can speak a little more about the basement part because we select a lot of ICP samples. So actually for the first order characterization of the basalt, the major minor elements or trace elements, they're very useful because we can tell you whether it's a oceanic island basalt, which is more enriched compared to the morph, which is mid-ocean rich basalt. So it's kind of surprising to me or to us as well because for this site, to see the composition of oceanic island basalt more on the surface, even though we're actually drilling a process on the South Atlantic mid-ocean ridge. Instead of having this more of mid-ocean ridge basalt throughout, we have a lot of oceanic island basalt, which would signal some kind of the hotspot movement instead of the source from the mid-ocean ridge. So I would say the major meta elements, even though they're not like very hard measurements, they are already very informative for the person.
Awesome. There's a question that just came in by Phil Sexton, and he is asking, how complete continuous are the recovered Cenozoic sedimentary sequences?
You'll have to wait and see, Phil. I'm not sure I can divulge just yet. But pretty good.
Okay, cool. There's actually a...
We're in the moratorium, we can't tell you.
There's a quick question for Andrew that Phil is asking. Have you written a letter yet to be sent via the mail buoy?
He's trying to trick me and think there's postal service to the phone.
No.
No
way.
We have Zoom. To Zoom, for this expedition, we're allowed a little bit of Wi-Fi personally, and then we can organise Zoom calls, so we Zoom back home to just keep in touch. That's been a nice.
So we're very isolated out here. I mean, it took us 9 days to transit out, and I've only seen. I mean, I haven't looked every day to be fair, but I've only seen one ship on the horizon, so and it's nowhere near us. So yeah, we're quite alone out here. I don't think.
You have whales.
We have some real whales, and we have a paleo whale.
Cool, awesome. Another question that's come through is, do you guys also sample manganese nodule around the area along with the core samples, or just the core samples?
We don't have any signals.
No. But one of our sedimentologists does study like manganese.
But they didn't see any nodules.
Yeah, we haven't seen any.
Maybe there was some
And we're not dredging here either. We're strictly coring for materials. So.
Okay. A question that's come through, Jay Fearon is asking, or is saying, I have a question for Yi. Your research on dioxia is really cool. Are you sampling oxygen in the water directly, or are you using proxies? If so, which ones?
So for this cruise, we're really lucky because we got the probes on board, so we can actually measure oxygen in the pore water. So this is what we were doing for the second course. We get the whole core and we throw the hole from the core liner. We put through this hole using that probe, and we start recording the real oxygen measurements from the pore water. We could actually match our IW measurements, like the pore water profile, with the oxygen well. So in this cruise, I can actually use both of the IW and my sediments. So for sediments, I use mostly the reactants to trace metals, nitrogen isotopes, and metal isotopes to reconstruct oxygen variability. But oftentimes, I didn't really have a lot of water data. But on this cruise, I can actually have the oxygen data with me to see what is going on in the pore water and compare with sediments.
Okay. A question that's come through, and maybe you can talk a little bit about this, is, are the samples available for research to other people? Is there any catalog to search for samples of interest?
Yeah, so we actually have a moratorium period. So at the moment, we're not sampling these cores for anything other than shipboard samples. And so we have our sampling, what we call sampling parties. We also did our research sample research request. And in November and January, we have our sampling parties where we go and heavily sample these cores. And from that date, we have 1 year of moratorium where only shipboard and shore-based participants can access the samples. And after that, they are available to anyone that requests through IODP. There is a website. If you go through IODP, there is a website, and you can see the catalog of all the available measurements, cores from from a very long time ago. And from there, you can request samples. Yeah, but we are the only people for at least a year to be able to conduct research on these.
Yeah. And I know Bremen Core Repository has their own sort of database, the sample requests, so you can see what's been sampled already, and then see what's left.
So there are 3 core repositories. One in the Gulf Coast, so it's at Texas A&M. One in Bremen in Germany, and then the Kochi core repository in Japan. And depending on which ocean basin you're drilling in, the cores will go to one of those repositories, and they are stored there for people to either go and visit them yourselves and take your own samples, or you can, I think sometimes they will sample for you if it's not an limited number of samples that you're requesting. But yeah, I mean, my PhD research was looking at samples from the North Atlantic, and my supervisor actually sailed on an expedition, but he sailed in 2012, and I've just finished my PhD now. So there's plenty of time between when you drill and when you can research. I mean, some people are still looking at like the legacy DSTP cores, so they're stored for a long time, and I mean, some have no sediment left or basement left, material left rather, but some are still pretty good.
Awesome. I think we have one or two questions more, and then we can wrap up this part. Another question that's come through is, does coarsening upward succession manifest in these core samples?
It's like a turbidite sequence.
Yeah. We don't have too many turbidites. Thank God, because we don't want turbidites. But yeah, you can see slight coarsening up or fining in sediments. Sometimes we get some silty.
Yeah, it's more like certain intervals. It's not like from the bottom all the way through the intervals, something, right? Yeah.
Okay, awesome. Thank you so much for answering all the questions. There is one more that I'm going to drop, and then just an announcement to everybody that there are the panel over here will be staying on for tea time. So if you have more questions, we can carry on this conversation then. There's a question for Andrew. From what are you deriving oxygen isotopes?
So typical measurement would be on benthic forams. So the sediments are mainly alternate between carbonates and clays. In those carbonate layers, you'll have a lot of benthic forams, and you'll measure the oxygen isotopes on those benthic forams, and that can tell you information about the paleo temperature or even paleo salinity of the selected time for that you want.
Okay, great. Yeah, once again, thank you everybody for asking these amazing questions. Thank you, Laura, for showing us around, and thank you, Claire, Yi, and Andrew for answering all the questions. I'm going to take over screen share and just do the outro. Yeah, okay, yep. Thank you everybody for joining us. Please fill out the weekly feedback form. Link will be dropped in the chat so that we can learn a bit more about who attended today's seminar. Join us next week where we will have Yassine Ait Ibrahim joining us from Morocco, where he'll be talking about hydroclimate variability in Northwest Africa and its potential implications on prehistoric modern human populations using speleothems. And up next is tea time with today's speakers, which will be an informal conversation about the talk in a relaxed setting. A question to think about is, as a potential icebreaker, is if you had to evolve into a dolphin or a whale, what would you be and why? And with that, get up, walk around, have a quick drink of water. I will start a 2-minute timer, and then we will see hopefully many of you during tea time. Thank you.